middle one's usually the analog, which is where you get the values.
Hey, for those of you that just came in, if you guys could please pair up with an existing group or form your own group of
Keep going.
people.
That's when I brought, but it's a little hard to do.
And if your group does not have an Arduino, please come up and get one in the front.
Yeah, we only have a couple left.
Make sure you have a machine with a working ID.
What's your name, by the way?
We're going to go ahead and get started with the workshop. Now,
I'm Chris.
So I'm assuming everybody has the files, the ID, and the deck if you're going to open up follow it. So we'll go ahead and get started. So as we were saying, I'm Rolando, Alex, and
oh yeah, I'm Juan, by the way. I'm
Yeah.
the HackUTD.
and Ryan is over here. He's going to probably float around after a little while to help you guys. If you get stuck, you can let him know. So, okay, the main thing is, how many of you know what an Arduino is to begin with? How many of you have used one before? That's about what I expected. Okay, so the Arduino, more so than anything, is just, it's a way to engage with the real world based on code. So it simplifies the job of having to try to get something to work through like sensors and any kind of motor, any kind of thing that you got to interact with. It just simplifies it down to just a simple loop. So it just does the same, it performs the same action over and over and over, just without having to do any of the other parts that has to do with code. So that's kind of the benefit of using the Arduino or any other microcontroller, because there's other versions of it. So this is the main staple is the Arduino, but there's the ESP32s, the 8266s, and there's a lot of SBRIF ones that kind of mimic the same thing, just at a smaller scale, and they have their own specific target group. Like some of them are Wi-Fi, some are Bluetooth, that sort of stuff. So that's kind of what the Arduino encompasses, is just to let you create things that you can interact with more so. All right, so I'm assuming you guys got the ID already. And in the files that you get, you're gonna get two separate files in each folder. So it's gonna be the actual file that you're gonna flash to the Arduino. There's just the running code. And then there's gonna be a sample file, just a little PNG file, that shows a schematic of the wiring. So you can follow along with that. And really, you won't really need to do a whole lot as far as programming if you're not comfortable with it. It's gonna run if you just open up that file in Arduino and you click the compile and run file. It'll just launch it and it'll just start working if you got the wiring correct. So the other part of Arduino is having the possibility of testing things out quickly. And so that's where the breadboard comes in. So it lets you just try things on the spot. If you want to try different kinds of sensors, different kinds of LEDs, the breadboard simplifies it so you don't have to do any soldering or weird crimping of things. This is the general layout of most breadboards. So the positive is always going to run vertically, depending on how you're holding it. Same thing for the negative. But the actual pinholes that goes to the sensors are going to run diagonally, the opposite way. So whenever you put any kind of sensor in, it's always going to have to be isolated amongst these two, like the way it shows you here. Whereas the power and the positive and the negative are going to go long ways. This is the first application, so it's just going to be the LED. And we put a little twist on it, so instead of just blinking, we did it to where it does the SOS, so urgency. So if you can go ahead and try to wire up the breadboard to where it kind of follows this, this diagram.
So connecting, let's see, one wire to from ground to the negative rail. another wire from one of the pins, pin number 2, to spots.
So one thing to keep note as, I know the background's white, this wire is white, so it goes to the second pin out of the digital pins. It goes to the, I guess you could say I2, if you look at it like that.
Red LED from 3J to. In that diagram, is that LED going from the 2J directly to the negative rail?
That's right.
No resistor?
No, it's
Okay.
because of the voltage being 3.3 volts
Okay.
coming out of the Arduino, it should be alright. Especially, I think these are 5 volt. So it should be alright.
All right, and one more wire, black one, that negative rail to the black. More for color coding.
Anyone need help? I can probably help you.
Download the Arduino IE. Oh, you're here? While we're here, probably going to tell us later, but go into tools, go to board, it's already on Uno, and port, click on concept. If you want, we should start trying to.
I mean, hopefully it works.
It'll work. Oh yeah, hopefully.
I mean,
Not
big of us.
exactly sure how.
It should work.
Hopefully they check it.
Did you upload it?
There we go.
Okay, there we go.
That's fine. You can just whatever it opens up. You're gonna open up I would think probably yes. You can check it first.
So we're gonna still
Computer science. Fourth year. Pizza dude. Can't believe I had dinner before coming. Can't believe I had dinner before coming. Oh well. More for everyone. I'd eat. FYI, are you familiar with Arduino? Yeah. FYI, how the functions is when it first starts up, it runs a setup function, and then it runs the loop function. It keeps running the loop function until it's powered on.
Yeah, we should.
Yes.
We don't like it. I think we should get this out.
Yeah, because they're working part of the way. Is there enough hardware for this?
There should.
Is everyone good with that one?
Yeah, honestly,
We're able to get it running?
Raise your hand if you're not able to get the wiring correct.
Not exactly. So the issue, so if you look at the schematic, and you can't, I know you can really tell that well, but on these two here, this one, that's what the numbering is. I know it's kind of weird looking, but that's actually, this one doesn't have numbers, but it would. So ideally, this one's gonna go straight to the ground. That makes sense. It's just it's weird because it was a picture. No, not in this case. In this case, yes. And I might have put it upside down just looking at it. Yeah, you can go ahead and try to run that. Yes. And then if it gets you an error, it'll be that's it. So it should be running around. So it might have been yeah. I think yes, yeah. So is everyone good? Everyone good? Good? Okay. All right. Sorry, so I'll go briefly through what's going on. What the first thing we did is we assigned LED with equals to 2, which is literally the pinout from the Arduino. They're all numbered for digital inputs and analog inputs, and the one that we chose was just the 2, number 2 on the side of the board. And then the setup, you're setting up that pin to be an output because it's going to be outputting the voltage based on the board itself. So that's what that's doing there. And then in the loop, we're just running the actual Morse code function over here. And these are in milliseconds, so it's 200 milliseconds. So it's doing that 3 times, taking a break for 300 milliseconds. And then it's going to the other ones, same way. And then the actual part of it where it's doing the blinking is just these over here. So it's calling this other one where it's doing the duration that it takes in based on the same one that is doing for it. So that's kind of what's going on with that. And from here on out, we're just gonna build on that. So this is gonna stay as it is. If you look at the other files, it's gonna be the exact same thing, just with one extra thing added to it, like 1 or 2 things. So now we're gonna do the button. So if you kind of, the best way to do it is to set it in the middle, where it separates it from the left side and the right side with that center ridge that it has. Yeah, the button. What's that? From thinking?
Yeah, stop it.
doesn't because you've already flashed it. So that's kind of the beauty of it is that it never stops. So if you lose power somewhere, like all of a sudden you lose power, it comes back on when power comes on. Yeah, this chip right here, this is you flash into this, like a ROM chip.
All right, second application. We're getting the button. Push switch.
So we're going A to
Analog tube. Yep. So that's going to go over this ridge. It would be on one side of the ridge. Some of the things would like read from each other. Almost like having power
kind of
and
runs in
ground
front
on
of
the
the
same
page, doesn't
rail.
it?
Should be alright. Should be alright in this box. Okay. So,
So now you just gotta do the wiring.
so we need to keep the LED. We can first focus on the button.
If you look
So-
in the same folder, you'll find that other picture that's the
Left
same exact
side,
thing. If you
it's
can't
gonna
see
be
this
going
too
into
well,
A2.
just check in the folder. There's a little picture of it.
Eight. Yes. It is. Yes. Yeah.
Either we can respond. Hey, can I get a picture of yours?
Yeah.
Oh, I like that.
A2. Yep. You have the right end. Sure.
Oh, it's not plugged in. This happens when you take like 3 years of like college. It's just, that's all I know. That's all I know. Just like, you plug it okay.
What it does.
Yes. Oh, okay. Maybe it reset.
Anyone need any help? You good? How many people have it working?
So it runs the when you press the button, it runs the Morse code.
Right, well, like, we press that button, so we don't do it.
In there, it has a thing where it checks to make sure like it's not someone's like spamming the button. If it seems spams button, it's not just a kind of undefined behavior.
I'll be on like the homepage of ACM, dude. Or HackUTD.
And there it goes.
I mean, we could literally just like do a basic too. You don't even need to.
well as the rest of us. We're just adding this in.
I'm gonna use it a couple times. I didn't realize that so
So it's gonna have a little tougher. It's gonna have a little tougher time getting in there. However, it's like yeah, it'll work. Most likely, this right side is going to be ground. The side on the left is going to be power, and the side in the middle is going to be Go ahead and just plug it into the power. Yep.
Oh, because I don't use the power twice.
We'll use the wings.
Oh, yeah, wrong.
There we go.
Make sure it's the same.
I'm guessing it changes the frequency. Oh, you haven't? Okay. Yeah, so all those just adjust the way. That's pretty good. It just keeps like coming off. Nah, dude, that's cool.
Decrease the delays between the on and off. LED. Actually, no, not even LED. In those.
I mean, have one blanket over too.
Oh wow, very good. Yeah, that was it. So you can play around with it if you want. If you want to change things on there.
But you just don't feel like the last one.
All right, so who still is working with one of them? All right, so I'm gonna go ahead and go to the next one.
What?
All right, so on that particular one with the button, all we really did was just added one extra constant
He's just like,
to control the button, which is gonna be on the analog, so A2. That's really the only extra thing, and then these other variables down here, that's to control the button, because what happens is reading it in the loop. So when you push it, it's just momentary, and so what happens is it goes one, it goes high, and then it goes low immediately as soon as you let go. And so if you're trying to run code off of that, it's gonna just run for that few milliseconds and it's over. So we're gonna be taking in the debounce is what it's called. So it's the in between the button being pushed versus what it actually is now, the current state. We're taking that into account, and then that's what it's kind of running on. And I'm not gonna get too much into it, but basically you gotta use the milliseconds. So you're comparing the current time versus the current time minus the amount you're taking into account to approximate what it's taking to press it. So that's kind of the gist of what that is. Aside from that, the rest of it is the same exact code from the other button one for the LED. Sorry. So the next one's going to be the actual potentiometer. In this case, it's going to be 3 different pinouts. It's going to be the current one, it's going to be the ground, and then the signal one that's going to get adjusted. And so just in here, I know I'll put it way out here, but it would have been covering up all the holes that are in the middle. So just kind of keep in mind that they go on the same spots as your wiring is going to go.
Yeah.
That's why it's super iffy. I'm telling you.
No, yeah, exactly. So I had to drag it off to the end. Yeah. I think if you're having trouble, you might have to, I know, kind of like Is it working for you? Okay. I'm going to go ahead and go to the next slide, just to kind of go over the code a little bit. So on this one, I added the extra constant for the potentiometer, call it pot. There's not really much different from the old code. The only difference is that I added the serial output. So if you open up the serial monitor, it'll show a 0 or a 1. And then when you press the button, it'll just say pressed. And as it's going, when you press it, that's when the LED is going to actually start to blink. And at that moment, if you start turning the potentiometer, it'll change the speed of the blinking itself. And it's going to show you the output of the actual, the value that it's getting in after it calculates it. It's going to print it out on the monitor. And then I did add like a little if statement, because the issue is if you end up adjusting it too far down, it delays the time equally. So you could be sitting there for 5 minutes or 5 hours waiting on a delay to timeout. So I ended up putting an if statement if the voltage goes below 1, just divide it by 1. So that way it doesn't last too long.
What's happening?
How come like on there you don't really mention like setting the pin mode for the pot pin number?
We set up the pin mode for setup.
You did it for the LED and the button, but you don't have one for the pot, for the potentiometer.
So,
Why is
that's
that?
my knowledge. The potentiometer just manipulates the charge and everything. It's we're sending charge through it, right? We're not.
And it only does it while it's
Complete answer. You're gonna definitely have to ask Rolando. But that's my knowledge. We don't exactly.
Yes, sir.
Send charge. Yeah. You should definitely answer this.
Sure.
So like, you set the pin
Yeah,
mode
honestly,
for the LED
that's even worse
and the
than
button,
some one of them.
but why don't you do like the setting the pin mode for the potentiometer?
I did over here, so it does it when it's reading.
Well, yeah, you do a read, but like you set like the pin mode for output and input pull up for like the button and the LED, but you don't do.
I probably should have.
Yeah. I think in the moment when I was writing, it didn't really occur to me to set the pin mode, but ideally it should. Yeah.
Okay, thank you.
But you wouldn't put like this one's got input pull up. You wouldn't do that
Yeah.
because it's gonna do that. That's the purpose. To just.
Thanks. Maybe we moved too fast. Too smart.
Does anyone need any help? Everyone good? Okay. Alright, so that concludes it. That's really it. I mean, that's really the gist of the Arduino. From here on out, it's kind of like what you get from it. You can kind of just make things you want. There's some examples for you guys. On the extreme side.
Wow.
That's it.
Okay, thank you guys so much for coming. We have just a reminder that we have our hackathon on April 18th. It's called Hack the School. It's a 12-hour hackathon. If you guys go to our website at HackUTD.co, there'll be more information. We do have pizza in the front if you guys want to come up and get some pizza. Thank you guys so much for coming.
Thank you guys.
Yeah. Again to Rolando.
Thanks for Joe.
Thank you.
Alright. Enjoy the pizza. I won't. Yeah. You go ahead and get in line. I'll do that. Yeah. Go ahead.
Also, in case you guys are still trying to get it to work and you don't see the wires going in the diagram, you can take a look here. Hopefully this will help.
If you guys are done with it, go ahead and bring it on the table. You can leave it on the table or bring it to the front. Right here.
Yeah, put it in the bag. Make sure you have all the parts. Don't pull the buttons down too hard, otherwise the legs will break.
Good luck in your classes. Have a good night. Thank you, you too.
What about one more show?
This is Camden. He's our HackUTD president.
I was just wondering,
I'm not that
You want to hold up a few of them and take a picture? Yes. Yes. The people that were in the workshop. Oh my goodness.
Yes. Oh crap. Okay. Okay. Thank you.
Yeah. Does the makerspace have like Arduinos, or can we just I guess like a spot?
I guess.
Would you want to like
Thank you
check them out? Like,
for watching.